This is the video for the notes 0.3 related to solving quadratic equations. Starting with what's labeled number 4 here at the top of the first page. We're going to practice simplifying an expression that will eventually be similar to a result from a quadratic formula. So we're going to start with simplifying what's inside the square root as much as possible. The square root of negative 12, we'll separate that into negative 1 times 12. So the square root of negative 1 becomes I, as we've discussed in 0.2. So we can take out an I. And then the square root of 12, we need to simplify that by looking for pairs when we need to find the exact answer. So 12 is 2 times 6. So the negative 12 is gone because it became negative 1 times 12. 12 is gone because it became 2 times 6. 6 becomes 2 times 3, so it's gone. So the negative 1 at the end of the factor tree branch becomes the I. We have a 2 and a 2 and a 3. The pair of 2's means a 2 also gets to come out of the square root, but the 3 that doesn't have a pair is going to have to stay inside the square root. So now this numerator for number 4 is negative 14 plus 2 times I times the square root of 3. We normally write numbers in front of variables. And the denominator is 2. And we need to reduce as much as we can, again, when it needs to be exact. So this dividing by 2 needs to go into both of the numerators if possible. If it can't do both, then you can stop, or you can separate it another way that I'll show you. So 14, negative 14 can be divided by 2, and 2i times the square root of 3 can also be reduced by 2, so you can separate it. Instead of keeping it all together, negative 17 divided by 2 is negative 7, and 2i times the square root of 3, outside numbers reduce with outside numbers, so 2 divided by 2 is 1. You can write the 1, but you don't have to. But you do need to write the I that's on the outside and the 3 that's on the inside of the square root. So that number 4 has been simplified, written in the form that they specified in the instructions, a plus bi, and it's exact. For number 5, simplifying that square root of 32, it's going to be 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So we have a pair of 2's here, another pair of 2's here, and then this 2 that doesn't have a pair. So the negative 8 plus stays the same for now. The square root of 32, we have a 2 that comes out from the first pair of 2's, a second 2 that comes out from the second pair of 2's, and then the 2 that has to stay inside that didn't have a pair, all over 24. So this is negative 8 plus 2 times 2 is 4, times the square root of 2, all over 24. And we reduce again if we can. Both parts on the top simplify with the numerator as much as possible. So negative 8 over 24 will reduce to negative 1 over 3 because 8 and 24 are both divisible by 3. And 4 times the square root of 2 over 24, 4 and 24 will both reduce by 4. They'll become 1 times the square root of 2 on top. You can write the 1 that's on the outside, you don't have to. And a 6 on the bottom because 24 divided by 4 is 6. Number 6, simplify the square root of negative 27 on top first. We negative 1 times 27, so the negative 1 is going to mean we have an I on the outside. 27 will become 3 times 9. 9 is 3 times 3. So we have a pair of 3's, 1, 3 that doesn't have a pair, and then that negative 1 inside the square root that's going to become an I on the outside of the square root. So 15 plus 3I times the square root of 3 over 21. When you're doing your own problems, trying several versions possibly if you have to try again, sometimes one of these fractions will reduce and the other one won't. Sometimes none of them will. These happen to all have fractions that reduce for both pieces, but that's not always necessarily going to happen. 15 over 21, those are both divisible by 3. So 15 divided by 3 will be 5, and 21 divided by 3 will be 7, plus 3I times the square root of 3, the outside number 3 on top, simplifying with the denominator 21 will become 1I times the square root of 3. Again, you can write the 1 on the outside, but you don't have to, over 7. Because these denominators are the same, these can be written together as one fraction if the directions allow. Sometimes in the online assignment, the requirement is like the number 4 earlier, where it has to be A, which is a number, plus B, another number, times the I. So not written together, but other times it can be written together. So together, if allowed, is fine when the denominators are the same, or separate is also okay when the denominators are the same, or if they're not, like example 5. The next section is solving quadratic equations by factoring. So we've practiced reducing answers that we're going to get from the quadratic formula when we get to that part towards the end of this video, but this section is just solving. So the directions are different. We were simplifying before, now we're solving. We've got a quadratic equation, so there's an equal sign, and when the directions say by a specific method, when you're turning in your work on something like an exam or an SLO, that's the method I need to see in your work for it to earn you full points. 1a, 3x squared minus 9x. We're going to first factor out any greatest common factor that we possibly can. GCF for short, greatest common factor. So both of these terms have a 3, and they both have an x. So we're going to factor, we're going to divide out. Basically, it's undoing the distributive property, whichever way makes sense to you. 3x squared, when we divide by 3 and by x, will leave us with 1x. Again, you don't have to write the 1. And then the negative 9x term, when we divide by 3 and divide by x, will leave us with a negative 3. Because negative divided by positive is negative, and x divided by x, there's no more x's left for that term. It's equal to 0. Once you factor out the greatest common factor, if there is one, the next thing to do is to set the factors equal to 0. So 3x, set that equal to 0. X minus 3 is equal to 0. And then solve those. And this one we're going to divide both sides by 3. So x equals 0. This one, we're going to add 3 to both sides to get that x by itself. So we undo whatever operation is there so we can get the x by itself. And it would be best to check our answer by plugging these x values into the original equation one at a time, making sure we get 0. 0 squared is 0 times 3 is 0 minus 9 times 0, 0 is 0, so that one is verified. And 3 squared, because we got to follow order of operations, so parentheses first, but we don't have any exponents. 3 squared is 3 times 3, which is 9, times the 3 that's in front of that would be 27. Minus 9 times 3 is another 27, so 27 minus 27 equals 0. So that answer, we've verified both of those. For 1b, this one is not set equal to 0 yet, so I should have written a couple more steps over here in my work for 1a. The very first step is to make sure it's set equal to 0. Sorry. Clean that up. So some of the problems will be like 1a where it's already equal to 0. Some will be like 1b where it's not already equal to 0. You need to do that first if it's not done for you. We're going to factor out the GCF, or factor as much as we can. If there's not a GCF, set the factors equal to 0, and then solve by getting the x by itself in each of those factor expressions, and then it would be best always to check. So for 1b, following the complete set of steps now, to get this equal to 0, first we are going to need to FOIL on the right hand side. So the left hand side is going to stay the same for a little bit. 4x times x will be 4x squared. 4x times negative 1 is negative 4x. That's f for first times first, o for outer times outer. Finishing up FOIL, I inner times inner, positive 9 times x will be positive 9x. And last times last, positive 9 times negative 1 is negative 9. So we have some like terms on the right hand side that we need to combine. 7 minus 7x equals 4x squared. A negative 4x plus 9x will be a positive 5x minus 9. And now to get this set equal to 0, we need to move everything to one side. Doesn't matter if everything's on the left, like for 1a, or if we move everything to right, like I'm going to do for 1b, as long as 0 is on one side and everything else is on the other side. So it's easier to move the 2 terms on the left than move all 3 terms on the right, in my opinion. So I'm going to subtract 7 from both sides. So negative 7x equals 4x squared plus 5x. Negative 9 and negative 7 when we add them, or negative 9 minus 7 is negative 16. Subtract or add the 7x to get rid of the negative 7x. So we need to undo that operation. So we get 0 on the left hand side equals 4x squared plus 12x minus 16. So we've got it equal to 0. Like I said, some will be already set equal to 0 for you, like 1a. Others you're going to have to do that part yourself. Once it's set equal to 0, we factor out the GCF if there is any. This equation, 4x squared minus plus 12x minus 16, everything has a 4 that I can factor out. So 4x squared, when I factor out, divide by 4, we'll be left with x squared. 12x, when I factor or divide by 4, will be 3x. And negative 16, when I factor out the 4 or divide by 4, will be negative 4. So I factored out the GCF, but that still needs to factor some more. The x squared plus 3x minus 4. I'm looking to undo FOIL for this expression, not the original expression in my problem, but this expression. So to get x squared, I know it's got to be x times x. And then for the last term, the number negative 4, there's some different possibilities. There's 1 and 4, 2 and 2, and could be positive, could be negative. I've got to figure out which combination of numbers will multiply to get me the last number and add to get me the middle number, with the different numbers and different positive and negative combinations. The combination that works here is if I have a positive 4 and a negative 1. Because negative 1 times positive 4 will be negative 4. That gets me the last number in my equation. And negative 1 plus 4 will add to get me the middle. So when I do the outer and the inner from FOIL, I'll get that middle from combining like terms, similar to what we did at the beginning. So finishing up those factors, one of them needs to be x minus 1, the other is x plus 4. The order of those two doesn't matter. If you write the x plus 4 first and the x minus 1 second, that's totally okay. We're going to set each of those factors equal to 0. To solve, we're almost done. For this first one that I wrote down, 0 equals 4, that's never possible. This doesn't have an x, so if you're doing what you're supposed to be doing, following the steps, but you have a number that came out by itself that doesn't have an x, that's not going to give you an answer. When we have x squared, there should only be 2 answers. They might be the same answer twice, but we shouldn't have 3 answers, so that first 0 being equal to the GCF 4 isn't getting us any of our answers we need for this problem. The next factor, x minus 1 equals 0, and we solve that by adding 1 to both sides. We get 1 equals x. And last, the factor x plus 4, when that's equal to 0, we need to do the opposite of adding 4, which is subtracting 4 on both sides to get x by itself. So I should check my answers by plugging them both in one at a time to the original problem, making sure they make that equation true. But I am going to stop the video there so that it's a reasonable length, and I will do another video for the remaining examples.